Bit of practice. Here we go. So, I see a 4 in both parts in the square root. So, doing a little algebra first, we have 5 over absolute value of x, square root of 4, square root of x squared minus 1, and the square root of 4 is 2, so I got 5 halves times 1 over something that looks familiar, at least to me, square root of x squared minus 1, which is the antiderivative of secant, or the negative of the antiderivative of arc cosecant. So the antiderivative here would be 5 halves arc secant, or secant inverse, plus c, or we could put negative in arc cosecant of x plus c. Okay, so we have x in the numerator to the 1 power, we have x to the 1/2 down here, so 1/2 from 1 leaves x to the 1/2 in the numerator, so this simplifies to 5/7 x to the 1/2 plus cosecant squared x, and hopefully I recognize all these to do the antiderivative. So here I would have to increase this by 1, so it would be 3 halves, so I'm going to have 5/7 divided by 3 halves, so times 2/3 x to the 3 halves. 1 more than 1/2 is 3 halves, and dividing by 3 halves is multiplying by 2/3. And the antiderivative of cosecant squared x, the cosecant ones make negative, so it's negative cotangent of x, because the derivative of cotangent is negative cosecant squared, so I have to do negative cotangent to get a plus cosecant squared, plus the constant. And I could change this to 10/21s, but that's fine. This one, let's do a little algebra again. Let's see, x squared minus 9, I think factors to x plus 3, and x minus 3, and that's over x plus 3. So this is very closely related to this, except for at minus 3. So the integral of x minus 3 is 1/2 x squared minus 3x plus c, as long as x doesn't equal minus 3. Which makes the denominator 0. Okay, this one. So the 4th root is like 1/4 power, so this is 6x to the 3 over 4, 3/4 power, plus 4/5 times 1 over x. Separating it out so we can see it more clearly. So adding 1 to 3/4 is 7/4. So I'm going to have 6 times 4/7, because I have to divide by 7/4, which is multiplied by 4/7, times x to the 7/4, and then antiderivative of this would be 4/5 ln of absolute value of x. And again, x cannot equal 0. Okay, x cannot equal 0 on this one. But the antiderivative of e to the x is e to the x, so we got 7 e to the x. Using the power rule here, we had 1 to minus 2, which is minus 1, and divide by minus 1, so we get plus 8x to the minus 1, or 8 over x, plus this part is 7 times 1 over x, so that's 7 ln absolute value of x plus c. Next one, 3x. That's the same as 7x minus x squared times 1 over 3 times x to the minus 1. Leave the 3 down, just bring the x up as minus 1. Multiply that, well, we'll multiply that all in, so we get 7 thirds, and x to the plus 1 times x to the minus 1 is x to the 0, or just nothing. And this would make it minus 1/3 x to the 2 minus 1 is 1. So I do the antiderivative, and I get 7/3 x. And adding 1 to 1 is 2, so I have to divide by 2, so I get minus 1/6 x to the 2. And again, x can't equal 0. All right, this one, x can equal 1. Now, let's see. Let's factor this numerator. This would be 8 plus x and 1 minus x, I think, because this would be 8. This would be minus 8x plus 1x is minus 7x, and that would be minus x squared over x minus 1. These don't cancel like they are, but if I take a negative 1 out of this, that would turn this to minus 1 plus x. So then a minus 1 plus x would cancel this, and so I have the negative of 8 plus x, or negative 8 minus x. So if I do the antiderivative now, negative 8x minus 1/2 x squared. This one, now we'll do a little trig simplifying. See, cotangent is cosine x over sine x. Cosecant is 1 over sine. So these cancel, and so this is just cosine x, and the antiderivative of cosine x is sine x. Okay? This one, secant squared, the antiderivative is tangent, so we get minus 5 tangent x, and minus cosecant squared is cotangent, derivative of cotangent, so we get minus 3 cotangent x plus c. C, 1 over secant. Secant is 1 over cosine, so this is just 5 cosine x plus sine x. The antiderivative of cosine is sine, and the antiderivative of sine is minus cosine. Tangent is sine x over cosine x. So the sines cancel, and the 1 over cosine becomes pi times cosine x minus x to the negative 7/11. The antiderivative of cosine is sine, so we got pi sine x. And the antiderivative of this, we add 11, so that'd be 18 over No, add 11 to negative 7 is plus 4. So we got x to the 4/11, and we have to divide by 4/11 or multiply by 11/4. And we didn't change the sign in there because that adding 1 made that positive, so we're dividing by positive, so that stays negative. Okay. This one looks like it could factor. Let's see. X plus 3 and x plus 1. And let's see, there's a 6x in common. If I take that out, I get x plus 3. Okay, so the x plus 3's will cancel as long as x is not equal to negative 3. And x can't equal 0. So then, this is like 1/6 x to the minus 1 times x plus 1, which is 1/6 x to the minus 1 times x is 1, and x to the minus 1 times 1 is x to the minus 1, or 1 over x. So I'm going to get 1/6. The antiderivative of 1 is x, and the antiderivative of 1 over x is ln of x. Okay. And finally this one. This is like 5/2 times 1 over x minus 3 times 1 over 1 plus x squared, and plus, and the fifth root of 32 is 2, so that comes out. And then we have x to the 7/5 root. So the antiderivative would be 5 halves ln absolute value of x. This is the derivative of arctangent, so minus 3 arctangent, or tangent inverse of x. It's 1 over 1 plus x squared, or x squared plus 1, doesn't matter. And then this, if we add 5 to this, we get 7/12, and so we have to multiply by 2/7, so we get plus 4, no, add 5, we get 12/5. So I have to multiply by 5/12, which would be 10/12. X to the 5/12 plus c. And ln can't be of 0, so x cannot equal 0. Okay, that's the practice sheet.